All right, so this is a review of all the functions that you'll need to be able to do on your calculator. So we'll run through all of these together. That way, hopefully by the end, you feel comfortable on how we can use our calculator to help us on our test. So the first thing is how we can find all of this data using our calculator. So most of this, if we type this into our calculator, will tell us for us. A couple of them we'll have to go back and actually find on our own. So the first thing we'll do is we'll want to type it into list one. So we'll hit stat edit. I'm going to go ahead and clear list one by highlighting it. Oops. Stat edit. I'm going to go highlight it, hit clear, and then enter. So that will clear list one for me. And then I'm just going to type all of these values into list one. And then you just want to make sure very carefully you don't make any mistakes, because that will affect all of your answers going forward. All right, so I typed my numbers into my list. So then to go ahead and find my answers, I'm going to hit stat, go over to calc, and then hit that one var stats. We put it all in list one, so we'll want to make sure it's typed into list one or calculating from list one. And then there are all our answers. So our mean is 47.4. Our standard deviation, we should be using the S of X, 1. So that's 8.67. Our minimum is 34. Q1 is 40.5. Scroll down, it tells us our median is 48. Q3 is 55.5. And our maximum is 61. So those are all the things that we can determine from our calculator that our calculator can tell us. The last three we have to find by hand. So remember, mode is what occurs the most. So if I look at my list, I'm just looking for numbers that repeat. I see a 56 here and here. I see a 42 here, here, and here. So there's 3 42s. So that seems to be the one that occurs the most often. I have 2 47s. Okay, so it looks like 42 is our mode. That one appears the most. So then our mid-range, we take our highest number, add it to our lowest number, and divide by 2. So in this case, we already know our min and our max. So 61 plus 34 divided by 2 would end up giving me 47.5. And then our range is just that highest number minus our lowest number. So using those same values, I would do 61 minus 34, which would give me 27. Yes, sorry, I've been fixing this to S of X because that's the wrong standard deviation. You want to find the S of X standard deviation for these problems. So go ahead and try and find these by hand. Pause the video. See if you can find this on your own using this data, and then I'll show the answers in just a second. Okay, so hopefully you paused the video and you tried these to figure out which one to find all of these values. So hopefully these are what you got. If not, I would go back and check your list. Honestly, that probably just means you accidentally typed in one of your numbers incorrectly. All right, so now if we want to make a box plot with our calculator, here's the steps. So we've already done this. We typed over all of our values into list one. So now we're going to go ahead and graph this, right? I have all of my values in list one. So I'm going to hit second y equals. I'll go to stat plot 1, make sure it's on. And then for type, I'm selecting this one here, that box plot there, second to last one. And then I'm telling it to pick out of list 1. And then once I'm ready and all of this looks good, I can go ahead and hit zoom 9. And there's my box plot. We can also plot this by hand, right? We've talked about we're going to make our number line. And our minimum is 105. Our maximum is 205. So we're going to need to go, we'll count by tens. And we just try to keep the size of each of these consistent. Okay, so my minimum is 105. My maximum is 205. Then I make a box between 116.5 and 141.5. Draw my lines. And then my median is at 128.5, goes through the center. So that would be my box plot. So then if I want to check for any outliers, remember first we need to find our interquartile range. So Q3 minus Q1, we know Q3 is 141.5, Q1 is 116.5. So 141.5 minus 116.5 would give us 25 as our interquartile range. So then we're going to use that value to check for outliers. So our two equations that we use, Q3 plus 1.5 times the IQR. So Q3 is 141.5 plus 1.5 times 25. And then I do 116.5 minus 1.5 times 25. 0.5 plus 1.5 times 25 is 179. And then I do 116.5 minus 1. And I end up with 79. So if any of my numbers are outside 79 to 179, they would be considered outliers. So I know that I have at least one at 205. I think the rest of them are good. Yeah, so I do have an outlier. Would be 205. Yeah, it's outside of our range of usual values. So then next, we went ahead and we made some scatter plots. So if we turn our paper over, yeah, scatter plots is when we're given an X and a Y value, or two values that come from each piece of the data. So this is kind of how these are all the steps for us to go ahead and make our scatter plot. So first we're going to want to type in all this stuff into list 1 and list 2. So we'll hit stat, go to edit, I'll clear list 1, clear enter, and then I'll type all of these into list 1 and all of these into list 2. I'll just make sure it's right because you don't want any numbers to be off because that will affect all of your numbers. And then you want to make sure that these line up correctly. So 1 with 98, 4 with 83, 5 with 71, 4 with 76. Okay. So we have our values in the list 1 and list 2. If we want to go ahead and look at our scatter plot at this point, we can. Remember, we'll go to second y equals. We'll turn our plot on, but we want to make sure it's our scatter plot one this time. It needs to come out of L1 and L2. So we need to change this to L2. To do that, we hit second and then the number 2. And then everything else looks good. We could hit zoom 9. So there's our rough sketch of our scatter plot. And we don't have to get super, like we don't need tallies. I would just make sure this is labeled, number of absences. And then this is grade. We're not going to label specifically anything, but we'll just put some dots kind of along the path. And then we're going to go ahead and find our linear regression. So that's how we do this part. So we'll hit Stat, go over to Calc, and then we're going to select number 4 out of list 1 and list 2. So we get that our A value is negative 5.37 and our B value is 100.38. So we'll write our equation right where we put in the number for A and the number for B. So negative 5.37x plus 100.38. Our R squared value is 0.907 and our R value is negative 0.952. Okay, so now that we have this line, we want to graph that so it shows up on our scatter plot. So we'll hit y equals, we're going to type this into y1, so negative 5.37, oops, forgot the decimal, x plus 100.38. And then we can hit, yeah, we already did all of this. We already turned our plot on, so we can go ahead and hit zoom 9. And it will show up through our graph. So it looks like it's looking something like that. That's our picture. Yeah, and we just made a sketch of it here. So when we discuss this fit, yeah, we have a negative R value and it's pretty close to 1. We can also tell that our points are pretty linear. So we would call this a strong negative linear correlation. Right, our R value is negative, so we know it's a negative correlation, and it's also linear. And the fact that it's pretty close to 1 means it affirms it's linear, and the fact that our graph looks pretty linear there as well. So then if we want to describe the slope, remember we take this value, and we're going to write it over 1. So this is your change in y over your change in x. So y for us was grade. X was the number of absences. So as your absences increase by 1, your grade, and it's negative, so falls about 5%. Okay, so then we need to make a residual plot. So again, all of our steps are right here that we follow. So we're going to hit Stat, Edit. We're going to leave these alone and go over to list 3 and highlight it. Hover over L3. Now we're going to press second Stat and go down to number 7, which is our residual. We hit Enter again, and there's all those residual values that we needed. So when we're going to first go, before we go too far, we're going to go to y equals. You can delete this or you can just turn it off, right? If you hover over this and turn this off, then it won't show up, or you can just delete it. We just don't want that to show up while we're graphing. So then when I go back here, I'm going to press second y equals. I'm going to go to my plot. The only thing we need to change is that we're now coming out of, and this is wrong, this is a mistake, L1 and L3. L3 is our residual now, so we'll hit second 3 to change that to L3. So then when we hit zoom 9, this is our residual plot here. So we can sketch that, right? This is our grade still. This line represents that line of best fit. So then this is how far each of the grades were from that line of best fit. And it looks something like that. So then another common thing we do with our scatter plot is we can make predictions or assumptions about other things to come from this. So it says a student has 5 absences, predict their grade. So we use that line of best fit that we have, negative 5.37x plus 100.38. And then absences was our x value. So this is x equals 5. So that means I'm going to plug in 5 for X and figure out what I would get for Y. So if I come here, negative 5.37 times 5 plus 100.38, I get that my grade would roughly be a 73.53%. And then if I would want to go the other way, so again, it's that line of best fit or that linear regression line that we use to tell us to make predictions or assumptions about other information. So if a student has a 70, so that's a grade, so that's a Y value, you can solve for X to figure out how many absences you would assume they had. So to get X by itself, I would subtract the 100.38 from both sides and then divide by my negative 5.37. So I would predict, right, I get that X is 5.65, so about 6 absences would give me a 70%. All right, so hopefully that was a good review. Yes, all of this stuff is going to be on our test, and we want to make sure we can solve this stuff using our calculator functions that we've learned.